So we're going to start our factoring review. So first thing, the methods that we have for factoring. The first way is what's called common factor, greatest common factor, GCF. We have by grouping, and we have our AC method. Each method is not independent. You could use all three of these techniques on a single problem to be completely factored. Most commonly, you'll have GCF with both of these. Grouping and AC method are harder to have in the same problem. Grouping requires 4 or more terms. AC method requires that you have at least 3 terms, even if the middle term is 0. We get the AC method from our standard form ax squared plus bx plus c. This is standard form of a quadratic function. So let's start with grouping. We know that it's grouping because there are 4 terms. What we do is we take the first 2 and the last 2 and we see what those 2 individual groups have in common. So this first one has a 7, terrible 7, and an x squared in common. So by factoring that out, by dividing that out, 42 divided by 7 leaves us 6. 3 x's, I took 2 of them, leaves us just 1x. The 7 is gone, so I still have this minus 1. And I took both the x's, so we leave a 1 placeholder. The second group looks like I can take a 2 from everybody. But what we need to do is we need to be able to create 2 identical binomials. So right now, if I were to just take out a 2, I'd be left with negative 6x plus 1. Very similar, but not exact. So to help us counteract that, we're going to take out a negative 2. What that does is it makes it a 6x minus 1. Now they are the identical binomials. Now that both of these terms, the 7x squared and the negative 2, both have this parentheses 6x minus 1 in common, I can actually factor out these parentheses just like how we factored out our like terms. And I get 6x minus 1, and I get the 7x squared minus 2. This is the only time all year that I told you guys, you take one of these binomials, you write it down, and whatever you have left goes together in their own binomial. We now check to make sure there's no greatest common factor in either of the binomials. There's no GCF here. No GCF here. What worries me is this squared. Maybe this is a difference of squares, where the first term is perfectly squared and the second term is perfectly squared. Well, 7 isn't perfect, 2 isn't perfect, so we don't have that. Our final answer remains these 2 binomials. Let's try another factor by grouping. First 2 terms, second 2 terms. Looks like the only thing they have in common is the x squared. That leaves us 7x minus 4. The next one looks like they can take out a negative 7. That leaves us 7x minus 4. We have x squared minus 7 is one of our binomials, and then we take one of the duplicate pairs and write them down. Now we check for greatest common factor. No greatest common factor there. Again, I see this x squared makes me think difference of squares. This one is perfect, but the negative 7, it is not. So this is our final answer right here. We also had factoring just by the greatest common factor. We can't use the AC method because C is not present. Even though if it's 0, we take 2 times 0. I need two numbers that multiply to 0 that add to 8. It's almost impossible to come up with. So when we have two terms like this, I look for greatest common factor. Looks like they both have a 2 in common, and they both have an n in common. We factor out the 2n. We have the n minus 4 left over when we divide everything by a 2n. Nothing left for us to do. We are done right here. On to our AC method. We've got our three terms. First thing I always check for is our greatest common factor. Looks like they all can be divisible by 3. So I take a 3 out. 3 goes into 105, well 3 goes into 10. 3, it's like 35. That 3 is just going to chill on the outside of this problem until we get to our final answer. So we do our AC method. We take A, which is 1. We're going to multiply it by C, which is 35. In this case, we get 35. I need two numbers that multiply to 35, but are going to add to 12. First ones I can think of that multiply to 35 is 5 times 7. 5 plus 7 is 12. And we have found our pair on our first try. We take n squared plus 5n plus 7n plus 35. That 3 is still on the outside. Now that we have brought this to 4 terms, we actually use grouping. The first two have an n in common. The next two have a 7 in common. So we have n plus 7, n plus 5, with the 3 that we've already taken out from the beginning, at the end. If you hadn't taken the 3 out at the beginning, at the end you're going to have one of these parentheses. It might look like this, where that greatest common factor is still a part of the problem. It could also just as easily have been in the other one, all depending on how you factored in the middle. Either way, the 3 can come out and it leaves us back to the 3 on the outside with our two binomial pairs. Let's try one more. Let's make it interesting. Let's do this one. Sometimes there isn't a greatest common factor, which makes A not 1. Nothing can come out. We use the same approach. 5 times this negative 8 gives us a negative 40. I need two numbers that multiply to negative 40 that can add to 18. My first thought, negative 8 and 5. If I add those together, I get negative 3. That is not the numbers I need. Maybe 4 and 10. Let's make it a negative 4. They add to 6. The numbers that we're actually going to need is negative 2 and 20. There's the 18. We split that middle term based on the numbers that we have circled over here. 4 terms we factor by grouping. I can take a 5x from the first two. I can take a negative 2 from the second two. So I get 5x minus 2 and x plus 4. No greatest common factor, no difference of squares. We are done right